Operation Castle, the fifth in a series of tests at the Pacific Proving Grounds. Another accumulation of men, of machines, another meeting of ships and aircraft and troops. Here was the best of physics, of metallurgy, of electronics. During the months after the historic Mike detonation, preparations for a new series of tests to solve the problems of a deliverable megaton weapon went ahead at an accelerated pace throughout the country. Operation Castle became a reality and is now successfully concluded. The report which follows is a summation of what occurred at the Pacific Proving Grounds during that operation in 1954. Here to lead off this record is General Clarkson, Task Force Commander.
Operation Castle was concluded on the 14th of May, 1954. Castle was an all-thermonuclear test, a test basically of devices in the megaton range. We feel that the report of this important test should give the failures as well as the successes, should reflect the changes in thinking that occurred during the test. We hope this treatment will help you understand the problems that were experienced during the course of the operation. This program encompassed then 3 shots on land and 4 shots on barges. Our main base camp on Bikini was located in the same island complex. The firing station to be used on all Bikini shots was located on Nu Island. Parry and Eniwetok Islands on Eniwetok Atoll again functioned as the center of land-based operations. This then was the weapons schedule and the operational plan for Castle of March 1st.
Parry Island, Eniwetok Atoll. This is the 3rd time this island has been used as the headquarters for a Pacific Task Force. For this operation, a weapons assembly area was constructed at the southern tip of this valuable piece of real estate. This is the first time on any operation that weapons were assembled on Parry and then moved out to the firing site. Weapon development would be impossible without diagnostic instrumentation. But such instrumentation is expensive, very expensive at this distance from home. For this reason, extensive instrumentation was limited to a few shots, and each diagnostic experiment was carefully considered before being included in the program. This instrumentation, while more elaborate than that of other shots, is representative of the type of diagnostic studies made. Recorders to read the yield of the primary bomb from its rate of neutron multiplication. Cloud sampling for radiochemical determination of fission yield, and to assist in determination of total yield. High-speed cameras and photo towers for ball of fire photography to indicate total yield of the device. Scopes recording electromagnetic radiation, and cameras, both to obtain the time interval between primary and secondary bomb detonations. Other cameras to look directly into the open door of the cab. A great mass of information was gathered as a result of an array of 12 evacuated pipes. These pipes are like peepholes, looking at portions of the weapon's case to pick up gamma and neutron emission from many stages of the reaction. Starting at H-48 hours, all personnel at Bikini Atoll were evacuated from the scattered islands and moved aboard task force ships. The only men to remain were the members of the firing party, protected in their bunker on Nu Island. Once more, for the first time since Operation Crossroad in 1946, Bikini took its place in the story of atomic testing. The date was March 1, 1954. This photograph was taken from an airplane at 50 miles. The width of the fireball at this time, about 3 seconds after detonation, was 4 miles. The frame size of the picture is 6 by 8 miles. The top of the fireball at this time, 40 seconds after detonation, was 5 miles above sea level. Proved that we can have a high-yield weapon weighing less than 10 tons.
The tremendous yield resulted in a serious fallout situation at Bikini and certain other atolls downwind from ground zero. This was the forecast wind direction. The actual wind was in this direction, some 10 degrees less favorable than forecast. Even so, the winds were within the area of acceptable fallout. However, the unexpected high yield caused significant fallout to occur on Rongelap Atoll, 110 miles distant, on Rongerik, 150 miles from Bikini, and on Uterik, 280 miles out. After the natives were evacuated, radiation survey teams were flown back to the exposed atolls, where studies were made and water and soil samples taken. Rongelap had a native population of 82. Evacuation was carried out on the second morning after the shot. Rongerik had no native population, but was occupied by 28 men of the task force. 8 men were evacuated by air at H plus 28 hours, and the remaining men soon after. Uterik had 150 natives, and they were also evacuated, although radiation levels here were relatively light. The removal of personnel from the contaminated atolls was done mainly by destroyers. These destroyers were attached to the task force primarily for security purposes, but were easily adapted for use as evacuation vessels. All of those exposed were taken to Kwajalein, where complete physical examinations were carried out. Every effort was made to assure their comfort and well-being. Fallout on Bikini temporarily rendered that atoll unusable. 25 R per hour was recorded on Eneman, our port of entry. On NU, the site of our control station, 35 R per hour was recorded. Hundreds of Roentgens per hour were measured on Aman and Bikini Islands. Even if radiation had not been a factor, blast damage on Eneman was considerable. It would have taken a sizable effort to make that island again usable as a base camp. The ground shock and fallout experienced by our firing party on NU forced us to give up the idea of a manned station. The necessary electronic systems were installed on the USS Estes to permit firing remotely by radio. The possibility of further damage to previously prepared shot sites at Bikini caused us to change our schedule at this point.
Back in the States, at about the same time Castle was in operation, the results of these drops, plus tested fusing and firing systems, made it possible to have a deliverable weapon ready, a weapon approximately 19 feet in length and 5 feet in diameter. While the case is made of aluminum, this is by no means a light weapon, since it weighs 43,000 pounds. It was put aboard its firing barge. This was the first time that the barge method of firing was used. It was felt that if firing could be done from a barge on open water, it would result in an appreciable reduction in fallout, as well as a considerable simplification of operational problems.
It proved a difficult shot to get off. We had to postpone 14 days from the scheduled date of firing because of weather. The winds continued to swing around, blowing to the south and then to the west. This took 10 days. Then for 16 days, the winds remained in this sector. Since Eniwetok was in this area, it might receive fallout if the winds were too close to a borderline condition. At 7 a.m. on the 26th of March, the forecast was for a favorable wind in the right direction. The shot was set for 6:30 the next morning, the 27th of March.
On this rather unimpressive barge, floating in the Bikini Lagoon, rested a device which carried the hopes for a large step forward in the weapons development program. The distance of the camera aircraft is 50 miles. The frame size of the picture is 14 by 18 miles. The film is running at normal speed. Looked from Inuitak Atoll, 200 miles away.
Daily commuting from ship to shore cost several working hours per man each day. We had to watch the radiation doses received by the people working on the test island. A maximum of 3.9 Roentgens per man was set for the operation, and with minimum readings of approximately 100 milliroentgens per hour, the men had to work fast.
As on previous tests, the armed forces took advantage of the Castle series to broaden their knowledge of the effects produced by high-yield weapons. As an example, there has been much uncertainty in specifying the minimum safe distance for aircraft delivering high-yield weapons. Blast and thermal effects were measured on B-36 and B-47 aircraft, positioned so that some damage was expected. This data will help us to specify the yield at which parachute drops are required for delaying a detonation, as well as providing us with answers to many questions which arise when positioning for multiple drops is considered. The whole picture of fallout contamination becomes of increasing importance with high-yield weapons. In one program, drone ships were sent into fallout areas to evaluate the worth of a washdown system for ship decontamination. We found we could measure fallout even in large ocean areas by making aerial surveys using extremely sensitive radiation detection equipment and with surface craft such as tugs and destroyers. As a result of these measurements, we were able to document for the first time fallout data from high-yield detonations. It is now known that fallout from the larger Castle shots blanketed areas of more than 5,000 square miles with radioactive material that would have been lethal to unprotected personnel. This one result gives a new insight into a method for using high-yield weapons in both strategic and tactical situations.
It is now around the 10th of April, and the recap of our story of Castle. 3 shots down and 3 to go. The weather continued to work against our keeping a firm firing schedule. During the middle 2 weeks of April, we were faced with the same situation. The winds above 10,000 feet were again in an unsafe direction. Under these conditions, populated areas were directly in line of fallout. Again, we postponed, awaiting a favorable forecast. This occurred on the 25th of April at noon.
Anchored in its location off the island of Urochi, 0 hour approached. The time of firing, 6:10 on the 26th of April. Camera position, 50 miles at 10,000 feet. Size of picture, 14 by 18 miles. Photographed at normal speed. The yield was 7 megatons.
The weapon was scheduled for firing on the 5th of May. This was 10 days since the last shot. For the first time in the operation, we had what could be considered a normal interval between shots.
On the 16th of April, a Strategic Air Command B-36 landed at Enewetak Island. Camera position, 50 miles at 10,000 feet. Size of picture, 14 by 18 miles. Photographed at half normal speed. The sixth and final shot of Operation Castle. This device was also flown out to the forward area for final assembly at Perry Island. The barge was towed directly to its 0 point at Enewetak Atoll. Here, over the spot that was once the island of Alujilab and is now the Mike Crater, was anchored in position. At 6:20 on the morning of May 14th, the smallest device of the operation was ready. This test initiated an investigation of small, lightweight thermonuclear weapons in the megaton class. Size of picture is 14 by 18 miles. The yield was about 1.7 megatons, essentially as predicted. From this firing, we learned that we have the capability of developing megaton weapons weighing less than 10,000 pounds.
Castle was by far the most complex and significant operation in the short but impressive history of nuclear testing, and in my opinion, absolutely vital to national security and the security of the free world. We were beset by operational problems of a magnitude not encountered previously. The degree of flexibility attained by the task groups and by the task force as a whole in meeting these problems is only one example of the spirit of cooperation evidenced by all members of the three services and by the members of the Atomic Energy Commission and its contractors. To the men who made Operation Castle a success, to the same men who were asked to undergo many personal hardships, I have already expressed my gratitude. I am sure that these men also deserve the sincere appreciation of the Department of Defense, the Atomic Energy Commission, and the people of the United States. This concludes the report on Operation Castle.